Hello, my name is Akaith, and today we're going to start our first video of HSA prep, and I'm a student in Long Reach High School. So our first lecture will be on water and the characteristics of water, and then we'll talk about how to find density, how to identify if it's an organic or an inorganic molecule, and we're going to look at the molecular formula and structural formula, and we're going to basically do a basic understanding of water. So the molecular formula for water is H2O, and the structural formula will be an oxygen connected with an hydrogen as I'm drawing it right now. So that's the O right there, and that's the hydrogen right there. And then the hydrogens come up like that because of the polarity, because as a result of the electrons swimming around the oxygen, so the electrons push up the hydrogens and they tend to rotate at that angle. So this is me describing it. So the oxygen is covalently bonded to the hydrogens. And now what does covalently bonded mean? So covalently bonded means that the electrons are shared, unlike the other types of bonds you've learned, such as ionic bonding. Remember, ionic bonding was when one of the elements completely got the electrons, but still had a bond. So the type of the specific covalent bond is a polar covalent bond because the electrons tend to be with the oxygen more than the hydrogens. So now we're going to talk about why water is an inorganic molecule and why other molecules are organic. And this will be discussed in other videos later. But for now, we're going to start off with water because water is one of the most ubiquitous things on Earth. So the main characteristic and the defining characteristic between organic and inorganic molecules is the carbon. And water has no carbon, so it's considered inorganic. As you see in the video, that there's a hydrogen, oxygen, and a hydrogen again, but there's no carbon. And as a result, that's why it's inorganic. However, here I'm drawing methane, and here in the middle there's a carbon, so that's why it's an organic molecule. And many other molecules are organic, so if you see any compound, any molecule without carbon, then you know it's inorganic. And here it's organic. And again, I'm stating, so any compound or molecule without a carbon is an inorganic molecule. However, methane has a carbon, so it's an organic molecule. And this is one of the important things that you need to remember and you need to know for the HSA test. Now we will be talking about how water is known for its characteristics and its polarity. So what does polarity mean? Polarity is a special attraction and it's a difference in attractions. So like nonpolar is something when the charges around that specific element or that molecule are equally distributed. Polarity, on the other hand, means that there are different attractions on different sides of that molecule. So for the water, you see that near the hydrogens, it's a positive, which means that it's a positive force, and then on the negative, it means that it's a negative force. And a positive force means there are not as many electrons as there are on the on the negative side. So that indicates that electron spin are located around that negative side more, and that's what it gives that side an negative sign. So the electrons spin more on that oxygen side that has the minus sign, so that's what makes it negative. And remember, these are important, like when you go into physics or later on, when negative and negative forces repel each other and positive and negative forces attract each other and positive forces repel each other. Now we're going to draw the structure, and we're going to show you how the atoms are exactly located and the electrons are located for water. So here we have oxygen, And you know oxygen has a number of 8. So what does 8 mean on the periodic table? 8 means that there are 8 electrons and 8 protons, right? So in the shells it goes 2, 8, 8. So here we have 2 on the inside and 6 on the outside. But for a shell to be complete, you need 8 electrons, but there are only 6. And then the 2 electrons that water picks up are in the green. And these complete the 8 shell for the oxygen, and it's complete and it's stable. And so the blue electrons are from hydrogen, and hydrogen gains one more electron, making it, having two electrons on its shell, so it becomes complete also. And that's the polar covalent bond between those two. And remember, protons and electrons are always equal each other, and then there's some special cases, such as an ion when the electron's number changes. But just remember that how to identify the amount of electrons and protons and the neutrons from a periodic table. This will be, you will further learn this in chemistry, but for now, you should know it for the HSA test. And then another special characteristic of water is that it's able to form bonds with other water molecules. So here I'm drawing water forming hydrogen bonds, which are that specific type of bond that forms with other water molecules. So you saw those dashed lines, those are the hydrogen bonds. And now, see, as I discussed later, how positives and negatives attract each other. The negative sides form hydrogen bonds with the positive sides of other water molecules. So the negative O side is connected with the positive H side of different water molecules, and here the positive side of the water molecule where the hydrogens are located form a hydrogen bond with the negative oxygen sides. And this again is a result of polarity. And so water is able to form 4 bonds, 4 hydrogen bonds specifically with when it's with other water molecules. And those are the hydrogen bonds again, and those are the dashed lines. So the 2 types of bonds present in water is the polar covalent bond and the hydrogen bond, which allows it to form, which allows it to interact with other water molecules. And then you will get a special characteristics that will be possible because of the hydrogen bonds. And so now, in order to calculate the density, which will be tested on the HSA test, it's mass divided by volume. Mass will be in grams, and then volume will be in liters. And then other ways they can test it is in milligrams and milliliters. And so there are many stages of matter. As you know, when you were a child, you used to freeze water and you got ice, and then when you melted ice, you got water, and then when you boiled water, you got vapor or gas. And so these are the different ways these 3 states of matter can be like how they take place. So gas can become a liquid, and liquid can become ice, and ice can become a liquid, and that liquid can become gas also. So from a gas, so a gas to an ice, okay, so gas to a liquid is condensation, and a liquid to an ice is freezing, as you know. And then ice to liquid is melting, and liquid to gas is boiling. And then I think gas to ice is just, I think it's just condensation again, and then ice to gas is sublimation. And you should remember these because these occur in nature. And in nature, you see that water evaporates when you place it out in the sun. And so these characteristics of water being able to change into different states of matters is important in life because it contributes to the survival of organisms, as you'll later learn. And again, these are the three states of matters, and then the way they can turn into each other. Now, we'll be talking about the properties of water. There are a couple of properties of water that you must remember for the HSA test. And the first property of water is that water is a universal solvent. What is a universal solvent? Uh, it basically means that water is able to dissolve many things, but not all things. And then the other ones are adhesion, cohesion, and the high specific heat capacity. Adhesion and cohesion refer to water's ability to stick to other water molecules and form bonds with other water molecules, and its also ability to also form bonds with other surfaces. And then the high specific heat capacity refers to the water's ability to absorb energy. And then water is also less dense than ice is less than dense than water, so it floats on top of water, which is important for life.